Hi, so for today we're going to talk about implicit differentiation and a topic in differential calculus. So for today's video, we're going to study how we are going to differentiate using implicit differentiation. So let's get started. So when using implicit differentiation, the rules in derivative are still applied, such as the power rule, the chain rule, the product rule, the quotient rule, and so on and so forth. So, but for this implicit differentiation, what are we going to do is whenever we are differentiating with respect to y, we have to leave, okay, a y prime, okay, after we have differentiated the y variable. So for example, in this implicit differentiation, so solve this using implicit differentiation. So we all know that this is product of x and y is equals to 1. So what are we going to do is both sides we must apply it or differentiate it, okay, with respect to x. So what will happen here? This is a product rule. So we have x, okay, multiplied by u dv plus v du. That's the formula for the product rule. So we have x times the derivative of y is 1, okay? But we have differentiated y with respect to x, okay? Plus copy dy, that's y, and differentiate x, we have 1 is equals to 0. So now we have x dy dx plus y is equals to 0. So what are we going to do with dy dx is simply dy dx is simply equal to y prime. So we are going to replace that by xy prime plus y is equals to 0. And then this y prime is the derivative. Alright, this is the derivative y prime. So what will happen here? I'm going to isolate y prime. So we have xy prime is equals to negative y, and we have y prime is equals to negative y over x. Now, if we replace, this could be the answer, okay? This could be the answer, y prime. Now, this can serve as the final answer. Just to check if we got the correct answer, we can simplify still y, okay? What is y? From our equation, we have y is equals to 1 over x. So what will happen if we replace y by 1 over x coming from this equation or from the original equation? So we have y prime is equals to negative 1 over x, and that results to negative 1 over x squared, which is actually the result if we are going to isolate y here and differentiate. What I'm trying to say is that we have the equation xy is equals to 1, and if we isolate y, we have 1 over x. And if we get the derivative of this with respect to x, okay, we'll get this. Okay. So this can be the answer or this can be the answer. If you don't want to simplify this can be acceptable, or also this. Okay. So but most of the time when we are solving implicit differentiation, okay, most of the time this y is not being converted back into the original equation because sometimes y is hard to express in our equation. So they leave it as it is. Okay. So this could be our answer. So for number 2, we shall try. Okay. Number 2, we have x over y cubed is equals to 1. So by loss of exponent, okay, I can bring this up. So to the numerator, that's x multiplied by y raised to negative 3. That's a basic rule. When you try to get the reciprocal of this 1 over y, you should negate its exponent. So again, this is a product rule. So I copy the first one and differentiate this. Negative 3y. We have minus 1 on the exponent, so this becomes negative 4. And that is multiplied by y prime. Okay? It's always y prime. That's a product rule. Plus, copy the second one. Okay? Then differentiate this x. So u dv plus v du. Okay? Is equal to the derivative of constant is 0. So simplifying, we have negative 3x y raised to 4 y prime plus y raised to negative 3 is equals to 0. So if I'm going to isolate y prime, okay, I try to isolate that by transposing this. We have 3xy raised to negative 4y prime. Try to get y prime by dividing both sides by 3x raised to y raised to negative 4y. We have y negative 3 raised to negative 3 over 3x y raised to negative 4. And furthermore, these two, y raised to negative 3 and y raised to negative 4, can be simplified. So we can have y raised to negative 3 multiplied by y raised to 4. Again, we negate the exponent when we get the reciprocal. So the negation of negative 4 is y raised to 4, and we have over 3x. By loss of exponent, their exponent will add, so negative 3 plus 4, that's y raised to 1, or simply y, over 3x. Okay? So this is now the answer. Of course, we can express again y from our previous, from our original equation, but most of the time it is leave as it is, as this answer, y prime. Okay? For number 3, I hope you get. Okay? Let's have x squared plus y cubed is equals to 4. Okay. So we differentiate, okay, all of the terms. So we have 2x plus 3y squared. If we are again differentiating with respect to y, there should be a y prime. Yeah. And that is equivalent to 0. Okay, getting y prime because that is what we want. Okay, isolating y prime, I transpose 2x on the right side. Then dividing this whole equation by 3y squared, we have y prime is equal to negative 2x over 3y squared. So this is now our answer. Again, another easy question for number 4. You have x squared plus y squared is equals to 2. Looks like an equation of a circle. So if we get the derivative of this by implicit differentiation, we have 2x plus 2y by power rule, and we have y prime is equals to 0. Okay? So we have 2y, y prime is equals to negative 2x. And of course, these 2's will cancel if we divide both sides by 2. So we have y prime is equals to negative x. So our answer would be y prime is equals to negative x over y. So this is our answer for this problem. Okay? So how about for number 5? We try to get the implicit differentiation of this 7y squared plus sine of 3x is equal to 12 minus y raised to 4. So again, we have to differentiate it. So we have 14y by power rule, 14y, and then we have y prime plus the derivative of sine 3x. First, you differentiate sine 3x, that's cosine 3x, and you're going to multiply it by the derivative of the inside function, 3x, with respect to x. So that is 3, cosine 3x. Is equals to, derivative of 12 is 0, minus, you have 4y cubed y prime. Because, again, we differentiate with respect to y. So, let me just rearrange this or simplify. So what are we going to do? We're going to isolate y prime. Okay. So if I'm going to transpose this 3 cosine 3x to the right side and this negative 4y cubed y prime to the left side. So we have 4y y prime plus 4y cubed y prime is equals to negative 3 cosine of 3x. So I can factor out y prime because it's both common to our two terms. So we have 14y plus 4y cubed is equals to negative 3 cosine 3x. Now, if I'm going to divide both sides by 14y plus 4y cubed, this will happen. So we have negative 3 cosine of 3x, okay, over, we isolated y prime, so that's over 14y plus 4y cubed. That is our answer for getting the implicit differentiation, the derivative of this function by implicit differentiation. Okay, so let's continue. For number 6, the only way for you to be better in math is to solve many problems. So let's try again. E raised to x minus sine of y is equals to x. So find y prime by implicit differentiation. So we know that the derivative of e raised to x is simply e raised to x. Okay? Minus the derivative of sine y is cosine of y, the whole function itself. And the derivative of the inside function is 1. And we have y prime because we are differentiating with respect to y. So we have this should be multiplied by y prime is equals to, with respect to x, that's 1. Okay, so if we manipulate this equation, so we have e raised to x, transpose this on the left side, we have e raised to x minus 1. And again, this at the right side, we have y prime cosine of y. Okay, isolating y prime, we get e raised to x minus 1 over cosine of y. And this could be rewritten as 1 over cosine of y multiplied by e raised to x minus 1. And 1 over cosine of y by trigonometric function reciprocal identity, that is equivalent to secant or secant of y multiplied by e raised to x minus 1. Okay? And this should be our final answer for this problem. Okay, let's proceed with number 7. Number 7 would be tangent of the x squared y raised to 4 is equals to 3x plus y squared. So what will happen, let me just change my color of my pen. So what will happen here, we differentiate this. First, the derivative of tangent x squared y raised to 4 would be secant squared x squared y raised to 4. And of course, we have to differentiate it. This is multiplied to the derivative of the inside function. And the inside function happens to be the product of x squared multiplied by y raised to 4. So we're going to use the product rule. So, product rule, we have x squared. Differentiate this. So we have 4y cubed y prime. Okay? We always have y prime because we differentiate with respect to y. That's plus, okay, y raised to 4. Then the derivative of x squared should be 2x. Okay? This is only the derivative of this. And that is equivalent to 3x. What's the derivative? That's right, that's 3. Plus, we have y squared 2y prime. Okay? So we're going to get or isolate y prime on the other side of the equation so that we get the result. So this is a distributive property, so I can multiply this. So this would be 4 times x squared, 4x squared y cubed or y prime, multiplied by this simply secant squared x squared y raised to 4 plus 2x y raised to 4 multiplied by this. Okay? Secant squared x squared y raised to 4 is equals to 3 plus 2y prime. So what happens is if I'm going to transpose this on the right side and as well as this on the left side so that I can factor out y prime, that's a good idea. Okay? So I have this. Then transpose this. So we have negative 2y prime is equal to 3. I'm transposing this on the right side. So this becomes negative 2xy raised to 4 secant squared x squared y raised to 4. If this is a minus, so I can factor out y prime. So y prime is equals to 4x squared y cubed secant squared x squared y raised to 4 minus 2y is equal now to 3 minus 2xy raised to 4 secant squared x squared y raised to 4. Okay, so I divide both sides of the equation by 4x squared y cubed secant squared y x squared y raised to 4 minus 2y so that I could isolate y prime. So the result would be 3 minus 2xy raised to 4 secant squared of x squared y raised to 4, okay, over 4x squared y cubed secant squared x squared y raised to 4 minus 2y. Now, you cannot cancel secant squared because we have a minus sign here, both for the numerator and the denominator. So we cannot cancel that. So, and this would be our final answer for this problem. So basically, we're going to simply differentiate them and isolate y prime to the other side of the equation. So this is our answer for this problem number 7. So let's try again another problem. For problem number 8, we have 4x squared, okay, y raised to 7, I think, minus 2x is equals to x raised to the 5th plus 4y cubed. So by uh, implicit differentiation, let's try. So I can first this 4x squared y raised to 7, I can this is multiplied between x squared and y raised to 7. Okay? So I can factor out that first, okay? First, and then I'm going to get the derivative of this. Okay? Going to get the derivative of this. So this 4 is multiplied in this x squared and y raised to 7. So I'm going to get the derivative of x squared and y raised to 7 by product rule. So that's x squared multiplied by 7, y raised to 6, power rule. Then we have y prime because we are differentiating with respect to y. Okay? And then plus, that's plus y raised to 7. Okay? Oops. Let me just rewrite. So y raised to 7, okay, multiplied by x, the derivative of x squared, that's 2x. So this is the product rule of x squared, y raised to 7. That's minus 2x, the derivative of 2x. Negative 2x is negative 2, is equal to x raised to 5, the derivative of that is 5x raised to 4, plus power rule for y cubed, that's 12, because 3 times 4 is 12, y squared, and we are differentiating with respect to y, so we have y prime in here. So we simplify. We simply simplify them. So we have 7x squared y raised to 6 y prime plus 2x y raised to 7 minus 2 is equals to 5x raised to 4 plus 12y squared or y prime. So distribute the 4. So I have 28x squared y raised to 6 y prime plus 8xy raised to 7 minus 2 is equals to 5x raised to 4 plus 12y squared y prime. And again, I'm going to transpose this on the left side and transpose this on the right side. And the same as the negative 2. So we have 28x squared y raised to 6y prime minus, we have 12y squared y prime is equals to 5x raised to 4, transposing this and this on the right side. You have minus 8xy raised to 7 plus 2. Factoring out y prime both of this term, okay, this one and this one. So we have y prime 28x squared y raised to 6 minus 12y squared is equals to 5x raised to 4 minus 8xy raised to 7 plus 2. Okay, and dividing both sides by 28x squared y raised to 6 minus 12y squared. So we have a y prime of 5x raised to 4 minus 8xy raised to 7 plus 2. Okay, plus 2 over 28x squared y raised to 6 minus 12y squared. So that is our answer. This is our final answer for this problem. Okay? I hope you are trying to get what I'm trying to say here. Okay? And last but not the least, for this video, problem for this video, and I'm going to leave you an exercise. So we have cosine of x squared plus a 2y plus x e raised to y squared is equals to 1. So how do we get the derivative of this by implicit differentiation? Again, we get the derivative of cosine x squared plus 2y as a whole. That's negative sine x squared plus 2y. And that is multiplied by the derivative of the inside function, that is 2x plus, okay, the derivative of y is 1, okay? So we have 2 times 1, which is 2, but we are differentiating with respect to y, so we have y prime here, okay? And then, plus, this is product rule, x and exponential. So we have to use product rule for that. So we have x, copy the first, and then we have differentiate the dv, u dv plus v du. We have dv here. So we have 2y y prime because the derivative of the exponent of e is y squared. The derivative of exponent of e, okay, should be 2y y prime. And then we copy the original function. That is multiplied. This is the derivative of our u, which is y squared. And we copy the original function. Okay. And that is plus, of course, copy the v, okay, and differentiate the u. So we have e raised to y squared, and then derivative of x is 1, okay, and that is equal to the derivative of 1 is 0. The derivative of any constant is equal to 0, okay. So what will happen? I can distribute this 2x plus 2y prime into this negative sign. So we have negative 2x sine x squared plus 2y, okay, minus 2y prime sine of x squared plus 2y. Simplifying this, that should be 2xy y prime e raised to y squared plus e raised to y squared is equals to 0. Okay, so I can transpose all of the y prime into the right side. So this one and this one. So we have negative 2x sine of x squared plus 2y. And then we have plus e raised to y squared is equals to 2y prime sine of x squared plus 2y minus 2xy y prime e raised to y squared. So what I'm going to do is to, again, factor y prime, okay, because it's common to this. So we have y prime times 2 sine of x squared plus 2y minus 2xy e raised to y squared. Okay? So again, if we are going to get y prime, if we divide both sides of the equation by this, we have y prime is equals to negative 2x sine of x squared plus 2y plus e raised to y squared over, we have 2 sine x squared plus 2y minus 2xy e raised to y squared. Okay, just checking if we didn't forget any sign. Negative 2x plus, then we have 2 sine. Okay, we got the correct answer. So this should be the final answer for our implicit differentiation. And before this video ends, okay, I would like to leave with you a problem so that you can work on. Okay, so your assignment, okay, you try on your own. Solve this. We have x squared cosine of y is equals to sine of y cubed plus 4x. This is y cubed. Okay, solve this using implicit differentiation. So if you're done solving, you may comment down your answers and let's see if you got the correct answer. So thank you so much for listening. This is again Engineer Abat. For more videos, math tutorials, and engineering tutorials, please don't forget to subscribe and check out my channels and all my other videos about a tutorial in engineering and math. So thank you so much and God bless.